had this now for a little over 1 year. It's been working very, very nicely. No problems at all with the machine itself. We had one retrofit on the yaw brake pads, which the manufacturer responded to promptly and took care of that. Other than that, it's run without any problems at all.
Is this thing paying for itself, would you say?
I would say that it is. In the first year of operation, 12 months, we made approximately 220,000 kilowatt hours of energy, and that's a cost savings to the taxpayers and the school of about $42,000.
$42,000
in 1 year, yes.
In 1 year, but how much did it cost to put it in?
It was around $600,000 total.
Total, and out of our own pocket, or
no? It was all donated. There were some donated funds. There was some grant money from the state. Very little taxpayer money. We spent a little bit for some landscaping around here, but it was negligible.
Now, as far as the way it works, are we selling back the electricity?
No. Everything that we make goes right into the building, and we use it right in the building.
Oh, we do?
Yes.
Why aren't we selling it back?
We don't make enough. There's a huge demand on campus here. We use roughly around about in this building about $500,000 or $600,000 a year in energy. So we use a lot of electricity powering all our fans and equipment at the pool and what have you. So it goes, and we need to keep our servers running 24/7. We need to keep some of our pumps and fans running 24/7. So
this alone can't be all of our electric.
No, it doesn't power the whole school. About 10 or 15% of our total.
You know, winter is really good for wind, and summer's really good for solar.
Correct.
When you look back at how much energy we were able to actually generate, because every time I look at this thing, it seems to be moving.
Yeah.
Even in the summertime.
Yeah.
What's the difference between how much energy
we make more energy in the fall and winter. We have stronger
How
winds.
Much more, though?
I'd have to go look at the data, but definitely more. There's more energy.
50% more?
Probably. We take a look at the dashboard for the wind turbine.
Yeah.
As you can see, it runs from my desktop. Data on there shows the current wind speed, meters per second. It's right now we're 9.2 or almost 10, which is about 22 miles an hour. We're making anywhere right now. We're making 650 kilowatts, and the wind's coming directly.
50 kilowatts. Now,
it's 100,
let's figure that out. This windmill is a what? A 50?
100.
It's a 100 kilowatt.
It's a 100 kilowatt machine.
What does that mean?
That means that maximum power output is 100 kilowatts.
And it's making 50 right now.
It's making 50 right now. So just the power, and you really, until you use it, then it becomes kilowatt hours.
Okay.
You can assign a cost to it. So costs are always based on kilowatt hours or how much power you use in 1 hour.
All right. Now, what is an average? Do you know this? What does an average home use in 1 hour?
In 1 hour?
One home. Or even a year. Would you know what an average home uses in a year?
Well, we can tell. We can go to public view and
let's go find out.
And I'll show you.
I'm really interested in, so people get a perspective on what these things generate.
Here's a good way to do it.
Right.
I would suggest, but then just you can see here, I can turn it off just by clicking this button.
Oh, really? You can turn it off right there. Yep.
And I can do this from anywhere. I can do it from my BlackBerry. So I monitor the machine all the time. I monitor on weekends, no matter where I am. I keep a close eye on this, and we make sure that it's always operating properly and safely, and we don't take any chances with it. So.
What do you really have to look at when you look at this?
I watch wind speed.
Yeah.
And I always watch the wind speed, and that's all I really care about. If I see that the rotor speed's not exceeding 59 RPM, and I'm not too worried. And it'll let you know. You'll start getting alarms. You'll get external condition alarms, wind speed alarms. It'll tell you.
What's the difference between the 30 mile an hour steady and a 15 mile an hour and it's still turning?
Probably about, it really starts making a lot of energy around 20 miles an hour. And at 30 miles an hour, it's at 100%. And I would say at 15 miles an hour, it's probably at 50%. So about 50%. You make a lot of energy in that last 10 miles an hour is where it really is.
Very good. Good to know.
All right. So this is my dashboard. However, if anybody would like to see what the machine's doing, and this is real time, you go to our our school website, which is npsk.org. And you go on the left side, you'll see a button for the facilities department. And we have a wind turbine public view link here. This is basically a snapshot of what the machine is doing. And you would ask the question about environmental offsets. We've saved $46,422 since installation, and that was since October 2010. Environmental equivalent's about 72 houses. We generated enough energy to power 72 homes.
Wow.
We've saved 6,455 trees. We've offset 310,000 pounds of CO2. So, I mean, there are things that we should all
And we
care
didn't have to ship it here either.
Environmental equivalent, driven about 491,223 miles of CO saved. Cars.
What about the noise? I mean, we're hearing things.
The noise you hear is the sound of the wind going by the blades.
Yeah.
In cold weather, the air is typically denser, so it's louder. On warm days, it's not nearly as loud as it would be on a cold day. It has to do with air density. This is an upwind machine, which means that it's always facing into the wind, and it's a little louder in front of the machine. If you go behind the machine, you don't hear it at all.
You can hear it.
You can hear it, and again, it's simply the sound of the wind going.
And it is
past
it is a steady windy day.
It's
right
windy
now.
today. I looked before we came out, and it's blowing about 20 miles an hour up there right now. The machine's making about 50 kilowatts, is about 50% capacity. So this is, it's a good day. We're making some good energy today.
So if this is using 15% max, making 15% of our electric needs, if we had 4 more of them, we could have 50% of our electricity?
Definitely. If we had 4 machines on a day like today, we probably wouldn't be buying any energy from the utility. We'd probably be making everything we use on ourselves.
Now, how do they react to that? I mean, I know that they're, they're in the business of selling electricity, though. I mean, just...
there's this regulation or constraint they have on the island of Nantucket, I guess, for limiting how much you can have, how much interconnect you can have into the grid, but I'm not totally familiar with what's going on. They've been very gracious to us. National Grid contributed a lot to this work here and helped us considerably in the installation. So they've been nothing but great to us.
Good. Is there talk about putting in more in?
Here at the school?
Yeah.
Not any serious talk. I'd personally like to do another one, but we haven't talked about it. We've got other things on our plate right now.
Yeah,
so.
sure. What about the maintenance on them? How much money does it cost to maintain them?
It cost us, this year we had first annual maintenance done on it was $3,000. So it's the first and second year in the period or in the series of maintenances are $3,000. The third year is $5,000. And then the fourth year you go back to $3,000, so there's like a 3-year.
Okay, so expect that cost too.
Yeah, so it's very reasonable, very reasonable.
Yeah, and do they come right out?
Come right out.
Are they a New England company?
We as part of the bid package, we contracted with Alteris Renewables, the folks who installed this machine, and they come and they do this service on it. They're certified by Northern Power, and they do all the service.
Is it American made?
Yes, it's designed, American designed. The tower was made in China. The rest of the machine was made in California and Germany, I believe.
Okay,
Parts.
So the blades might be German?
No, the blades are from California.
Oh, they are?
Yep.
So maybe the turbine's German? Or
not
just
sure.
parts of
So
it?
the components, and they come from all around. There are some American components. I believe most of the electronics are American. In the event of a high wind warning or high winds, it monitors the wind speeds. It samples every 10 minutes. It looks at an average. If the wind speeds exceed about 45 miles an hour, or if the rotational speed of the rotor exceeds 59 RPM, it will turn itself off.
Okay.
If it sees gusts, sustained gust of 70 to 80 miles an hour, it will turn itself off.
Okay.
It remains powered up so that it could yaw, and that means that it turns itself into the wind. It just reduces the amount of stress on the components, on the blades, if it's always facing the wind.
It uses its own electricity to turn it.
It uses its own electricity to turn it. But if it's not rotating, then obviously we have to pull electricity from the grid to power it.
Oh, I see.
And we have bidirectional lines going up to the machine to do that. But it's got its own microprocessor up there, and it monitors everything.
Can we look inside the
Absolutely.
door?
Sure.
So we can't go in it though. You can't go up to the top.
No,
you'd have to. Alteris would have to train you.
You need to be trained. You have to have training, which is provided by Northern Power.
Okay.
And they've invited me up actually to Vermont to their factory for the training. I just haven't been able to do it yet.
Oh, that would be very interesting.
It would be fun. I'd like to do it, then I can go up there. But you need to learn how to use the harness and all the safety stuff. It's a long climb. It takes a while to get up.
Yeah. How high is it?
135 feet to the center of the rotor.
And then the top of the blade would be?
That's another, I think it's 157 feet or 158. I don't recall.
The total height?
Yeah, to the top of the rotor. The sound you're hearing now is what they call resonance, and it's just the sound.
Oh, it is coming through the pipe.
Through the tube. It's amplified as it comes down the tower.
Like you can't hear it anywhere else, but
no, you can't hear it except here.
And
you can only hear it at certain frequencies. It's common, nothing to worry about.
Did you have an interest in this kind of technology before you?
Yeah, actually, I did. I've worked in nuclear power plants.
Oh, really?
In the past, had some involvement in college in the development of a wind turbine.
What did you do at the nuclear power plant?
I was a cost schedule engineer for Bechtel Power at a nuke plant in Pennsylvania that was under construction. Susquehanna.
What do you think about nuclear power?
I like nuclear power.
Yeah.
So here's the inside. So this is just give you a little idea of what's up on top there. But here's the rotor and the blade, the rotor hub. This is the generator. The rotor attaches directly to the generator. This is part of the body, the housing, or what's known as the nacelle. And then back here we have the inverter, and also the computers back here. So as you can see, there's not a lot up there. There's no gearbox, and the energy is transmitted directly to the inverter, and then it comes down the pole to this black cable into this disconnect, and through, and then people are building.
What have you found most interesting about this in the year that you've had a chance to really look at it?
Probably the most interesting thing is how efficient it is, and how it makes energy in little wind. I mean, 10-mile-an-hour wind, and we're making a fair amount of energy. So it's a very efficient machine.
Now, and that's the other point I was going to make. I was listening to, I don't know, some news channel, and they were talking about the technology 20 years ago, what the difference between where we are today as we were 20 years ago. The technology and the turbine and the blades is so much more advanced.
Definitely.
There's no stopping wind energy now, is there?
Well, I was recently in Europe. I was in Spain and took a train from Madrid to Barcelona, and I was amazed at all the wind farms I saw in Europe. You travel a lot, so I'm sure you've seen the same, but it's amazing when you go to Europe. They're everywhere, and I think Spain's powered by wind.
Yeah, they've got a lot of money invested in their wind technology.
They're everywhere. Yeah, it's
everywhere there.
It's interesting. So I think it's only a matter of time. I know people don't like looking at them, and people need to get used to that, which hopefully in time they will.
Well, I mean, look, our energy needs are not going down. I mean, when you think about how much energy we need, and then China.
People still like to use energy, and it needs to come from somewhere. It's clean, it's renewable,
and it's local.
And so, but it's there's pros and cons, and I understand why people don't like it, and what their concerns are, and they just need to deal with that.
Dave, I want to thank you.
Sure, my pleasure.
It was very interesting.
Great.
We appreciate you taking us on a tour.
Anytime we can show you anything we have here, we'd like to.
Thank you.